Here we are discussing some important properties of the chapter inverse trigonometric functions. This is theorem number 2. Here we have to prove that first sine of sine inverse x is equal to x, where x belongs to the closed interval minus 1 to 1. Second, cos of cos inverse x is equal to x, x belongs to the closed interval minus 1 to 1. So all these 6 formulas, these are important formula, and pattern are exactly similar. This is sine of sine inverse, this is cos of cos inverse, tan of tan inverse, cosec of cosec inverse, sec of sec inverse, cot of cot inverse. Each of these is equal to x. We have to remember this range only, okay? The values of x here in this case varies from minus 1 to 1. In cos of cos inverse x is equal to x, again x varies from minus 1 to 1. For tan of tan inverse x is equal to x, x belongs to the entire set of real number. So there are some differences in this ranges also that we are supposed to remember. So let us prove some of this formula and some of these theorems, and rest I will leave for you. You have to try it, and if you find any difficulty, write in the comment box. So let us see the proof here. First we have to prove that sine of sine inverse x is equal to x, x belongs to the closed interval minus 1 to 1. We'll start it from supposition that sine inverse x is equal to theta. Let sine inverse x is equal to theta. Here x belongs to this closed interval minus 1 to 1. Okay, so as sine inverse x is equal to theta, we can write sine of theta is equal to x. You know, sine inverse x is theta, then sine theta is equal to x. Now simply here we have to put the value of theta, we will get the result. Or this is sine of, in place of theta, we have to write sine inverse x. Sine inverse x. This is equal to right side is x. X will belong to the closed interval minus 1 to 1. So this part has been proved. Very interesting. Similarly, we can do second part also. Here we have to prove that cos of cos inverse x is equal to x. X belongs to the closed interval minus 1 to 1. So here also we'll start with putting cos inverse x is equal to theta. So let cos inverse of x is equal to theta. Here x lies between the closed interval minus 1 to 1. So cos inverse x is equal to theta, it means cos theta is equal to x. So therefore cos of theta is equal to x. Simply here we have to write the value of theta, we'll get the result. Or cos, in place of theta we have to write cos inverse x. Cos of cos inverse x, this is equal to cos theta. In place of theta we are writing cos inverse x, right hand side is x. So here x belongs to the same closed interval minus 1 to 1. So second part of this theorem has also been proved here. So these are very similar proof, exactly same pattern, just we have to put sine inverse x is equal to theta, cos inverse x is equal to theta, tan inverse x is equal to theta, cosec inverse x is equal to theta, sec inverse x is equal to theta, and cot inverse x is equal to theta, and we'll proceed similarly. We'll get the result very easily. But formula are very important, so you are supposed to remember this formula. These are very useful in solving the problems from this chapter. So remain in touch with these videos. We have to see some more important theorems, and later on we will see some questions also. So please don't miss to remain in touch with this video, this channel, and please share this video with your friends also. And if you are enjoying these videos, your likes are most welcome, and hope you have subscribed this channel. Wish you all the best.